Hi, I'm Arun Chaudhary. This is my Physics Lab 3 magnetic field of a bar magnet. So the introduction: in this experiment, I would attempt to measure the distance dependence of magnetic fields and compare it with the predictions from Biot laws, and use these two formulas to find the magnetic dipole of the bar magnet. The fundamental principles are as follows: Biot laws of dipoles, distance dependence formula, and the superposition of magnetic fields. So the system in this case is the bar magnet and everything else is the surroundings. Preview of results. So the dipole moment was found out to be 2.20, and the n in the formula was found out to be minus 2.4. So the assumptions in this experiment, the main assumption we're making is that the bar magnet acts like a magnetic dipole to model it through Biot laws. Then the experiment. So the procedure is as follows: the bar magnet was placed on one end of the ruler. Then the location of the magnetometer on the phone was found by sliding the phone perpendicularly to the ruler, both vertically and horizontally. This I was able to pinpoint the location on the phone where the strongest magnetic field was being read, which is as follows in the images. So following is the data that I got from the experiment. I used the distance dependence formula, B is equal to K times R to the power n. And by applying the natural log on both sides, I was able to linearize the equation below and plot it down to find the gradient, which is n. And the on-axis distance from the bar magnet was found for several magnitudes of the B field, as we can see in the spreadsheet. And then finding the off-axis field. So following the steps in the spreadsheet and the instructions in the lab, on the left, I was able to find the off-axis field of the bar magnet, which came out to be 6.3566 into 10 to the power minus 5 Teslas. Then some of the key observations were the readings for the magnetic field in the xy direction became 0 when the magnetometer was far away from the magnet. When the magnetometer was moved closer to the magnet, the x component of the measured field increased. And since this is a dipole, the strength of the magnet, I believe, should be proportional to 1 by r to the power 3. And the position of the phone mattered in terms of ensuring accurate readings, and that the magnetic field of the Earth doesn't interfere with the readings of the magnet. Then a calculation. So from the spreadsheet and the data, the linearized distance dependence equation came out to be this. So from this we can conclude that the n was minus 3.039, ln k was minus 14.63, and therefore k was 4.42 times 10 to the power minus 7. Using the Biot law to find the magnetic dipole, we found out the dipole moment to be 2.20. And then this is the glow strip code. So on line 18 we defined the magnet. From lines 49 to 54 we defined the different axes that we used. Lines 69 to 87 is code to calculate the magnetic field. And at the very end is the message that prints out if the code runs successfully. So these were the results that I got from the glow strip code. So the off-axis field from the code / model came out to be 2.71 times 10 to the power minus 5 Teslas. However, from the experiment that we did just before this, the off-axis field was found out to be 6.39 times 10 to the power minus 5 Teslas. There's a considerable amount of difference of 81% between the theoretical field and the actual field that we calculated in the experiment. So in these images we can see the different axes and the distance and all that. So the error analysis. The following are the sources of error that could have happened. So since the location of the magnetometer affects the results so much, there's a small chance that the location of the magnetometer was found incorrectly, which could affect the accuracy of the results. If the magnetometer's reading in the beginning was incorrect and didn't match that of the Earth's actual magnetic field, it could also be a potential source of error. Finally, the what if question. So what if I hadn't oriented my experiment to compensate for the magnetic north and had instead laid out my meter stick at some intermediate angle with respect to the Earth's magnetic field? How would my results change? So I believe the results would be less accurate, since the Earth's actual magnetic field would have interfered with my experiment and skewed the results. In that case, I would have to somehow account for the Earth's actual Earth's magnetic field by subtracting it from the total magnetic field. Now, what if I was to stick two identical magnets end to end and run the experiment again? I believe the magnetic field would double since the strength of the magnets collectively is greater than just one. Hence, the measurements I believe would roughly double. Therefore, we can conclude that both the models, Biot-Savart law and distance independence, can be used to model the bar magnets as magnetic dipoles. Thank you.